What's up, my mathletes? This is Chapter 2, Section 2, Day 1, the Algebra of Functions. I want to direct your attention up here. So just to give you an example, we might have two equations that you're graphing, and you can add equations. It definitely works out. Y1 plus y2 could just be 3x plus 4. You're adding all the like terms. Notice what happens when you add functions together is, if you have this function and this function, you just combine their total heights. So it would look like this up here. This height plus this height is this height. You can see it's like 2.1 or so, and then 3, and then the total is 5.1. Anyway, adding functions is just one of the things you could do. You could also subtract functions, or multiply functions, or even divide functions. So check this out. Given that f of x is equal to x plus 1 and g of x is equal to square root of x plus 3, find each of the following. F of g of x. Well, f of g of x really is just the same thing as f of x plus g of x. And so, just reading the definitions, we get x plus 1 plus square root of x plus 3. And carrying that work further, if you wanted to find f plus g of 6, then you could say it would be $10. You can get that two ways. You can find the function first, like we did, and then plug 6 into it. Or you could find f of 6. So f of 6 plus g of 6, you could find the values individually and then add them up, 7 plus 3, to get 10. Two ways both yield the same results. Let's do it the second way here. This is really going to be f of negative 4 plus g of negative 4. Well, f of x is x plus 1, so this is negative 3. And this is going to be the square root of negative 4 plus 3. We're going to be asked to find the square root of negative 1. And we can't do it, so this is going to be no real solution. Notice that in order for it to work, the value that you give here has to be in the domain of both f, which it was, and g, which it wasn't. You can't take negative 4, g of negative 4, so therefore you can't take f plus g of negative 4. G divided by f of x, that would just be g of x all over f of x, which is the same thing as square root of x plus 3 all over x plus 1. Alright, let's find the domain of these functions individually. I'm going to color code them. So here the red function, we have to make sure that this one, 5 plus x, is greater than or equal to 0. Subtracting 5, not a big deal. We get x is greater than or equal to negative 5. We can even plot that, negative 5, and shading. All of these numbers will satisfy. Then over here, blue function, we have to make sure that 5 minus x is greater than or equal to 0. Adding x to both sides, you get 5 is greater than or equal to x. And so therefore, and flipping it around, you can say this. So here's 5, and it's shading in this direction. So the question is, what is the domain of f plus g of x? So that would be the square root of 5 plus x plus the square root of 5 minus x. There's only certain numbers you can actually plug into this function. And what you have to do is you have to find the intersection of the previous two functions. Where do we see both red and blue? We see both red and blue right here. In the middle. Wish I had purple. Okay. So the domain for this total function is going to be from -5 to +5. If you try and put a number outside here or here into the function, then you're going to get a negative number somehow, either here or here. What we call that is the intersection. And you could say like the intersection of -infinity to 5 with -5 to infinity would be -5 to 5. That's how you could write it. And this would be your answer. That's what we call the intersection. Where do they overlap? Okay, so in general it looks like this: f plus g of x, f minus g of x, f times g of x, f divided by g of x. And you can simply replace the definitions as you see it. By the way, did I mention that Sacramento is the capital of California? Again, Sacramento is the capital of California, and I had a great time the one time I was there. Wonderful, beautiful place to visit. Start assignment 2B1, copy the problem list into your composition book, and do the first problem. Bring it to class, and I'll see you then. Take care.